Hope everyone can see. More people are trying to join. Everyone can see the slides, right?
Yes, sir.
Okay. So in the first class today, we will see the reasoning. So I think most of you have heard about reasoning. Have you heard about reasoning earlier?
Yes, sir.
Okay. So reasoning is important in artificial intelligence and machine learning. So we will start from the basics only. So reasoning is much more required as the processor and techniques that allows the machines to make inferences, draw conclusions, and make decisions based on the data. So that's why we start with reasoning. So basically, the reasoning is the mental process of thinking, deriving logical conclusion, and making predictions from available knowledge, facts, and beliefs. So suppose you have some existing data. So based upon that data, you have to do the logical thinking, how you will predict and what you will predict from the data you have. So reasoning is much required for decision making. We have to make some valid conclusions based on our data. So the machine has to think just like human, how we interpret something from the data we have, and based on that we do our logical reasoning. What is what we can predict and what we can think further from the data we are having. So one example we can see that we have two premises, and so two statements we have here. So let me allow.
পাঁচবেলাহে মাতিছে
First premise it's telling that parrots are birds, and second premise is telling all birds have wings. So if we are asking the question, do parrots have wings? Then we can conclude that
বটলতে ভৰাই
parrots
থৈছো
have wings. So from here we have the statements what we are considering as data we are having. So from that data we can conclude, and we can have questions based upon that data also. So for that question we can have our conclusions. So this type of reasoning we are applying in AI/ML. So these there are some applications in of reasoning in AI/ML. So natural language processing (NLP) we can uh, have the application of reasoning where AI uses reasoning to understand context, infer meaning, and generate coherent responses in conversation systems. So NLP is a subfield of AI where the interaction between computers and humans takes place through natural language. Siri or Alexa, you must have heard. Google Translate speech to text applications like Google Speech to Text. So voice recorder apps where you can record your voice, and similarly you will get the text output. So that kind of things we can see as example in NLP. So Similarly, recommendation systems where reasoning helps the systems to infer user preferences based on past behavior and similarity to other users and giving the personalized suggestions. So I will take one example. So while shopping on Amazon or Flipkart, suppose you are searching for a particular product. So based on that product, the application will automatically gives you some suggestions that similar kind of things are there. So you can see these similar products have been already searched by the users related to that particular category. So based on that category, what you are searching, so that is recommended by the system to you. Then another application you can have is automated decision making. So in domains like finance, healthcare, the reasoning algorithms assess the risk and makes the decisions based on the complex criteria and the past data we are having. So algorithms are used for that to do the data analysis and make the decisions without any human intervention. So some examples we can have is credit score. So many of you might have not heard or may have heard about the credit score, CIBIL score, what we generally say. So based upon that, the banks or the financial institutions provide us loans. If someone is having CIBIL score uh, already prescribed by the financial institutions, that this is the minimum threshold what we can consider to, based upon that the user can get the loan or not. So these decisions are made just based upon the reasoning by the system. Then the credit card transactions are also analyzed by the system upon the automated decision making to analyze the unusual spending patterns of the user. Then similarly, robotics also uses the reasoning to navigate environments, then plan actions and respond to the changes in real time. So the robots, different kinds of robots, drones, uses the same reasoning for the decision making. Then we will now move on to the different types of reasoning. So we are having deductive reasoning, inductive reasoning, abductive reasoning, common sense reasoning, monotonic reasoning, non-monotonic reasoning. So these are some of the types of reasoning. First, we will move on to the deductive reasoning. So it's basically, you can see here, the reasoning is deducing new information from logically related known information. It's already you are having some information which are logically true, and you are deducting the conclusion from that. So both the information you are already having is correct, logically correct, and also the conclusion you are deducting from that is also realistic and it's correct. Then we can say that it is deductive reasoning. Means both the conclusion and the uh, your information must be correct, must be true. So it is a type of proportional logic in AI, which we will be looking after uh, completing this reasoning propositional logic in the next session. So it requires various rules and facts. Based upon that only we can uh, have deductive reasoning, and it is referred to as top-down reasoning and contradictory to inductive reasoning. In the next type, we will see about the inductive reasoning. So basically, the deductive reasoning is the logical process where conclusions are drawn from general principles or theories. And the general argument is made to give the specific reasoning. Here we will see one example. First, we were taking the premise one. All the human eats veggies. And second premise is telling Suresh is human. So what conclusion you can make based upon that? Suresh eats veggies. Based upon both of the premises, we can conclude. So both the premises are logically true, and the conclusion is also true. So our information, both informations are logically true. So that's why we are deriving the conclusion, and it is true only. More people are trying to join. Let them join. So here we are explaining it with a diagram. Theory, then hypothesis, patterns, confirmations. So we have already seen that how the deductive reasoning is taking place. So it starts with a theory to provide a broad understanding of a phenomenon. Then we formulate a hypothesis based on that theory to make specific predictions. After that, we observe the patterns in the collected data through experiments or observations that is related to the hypothesis. And finally, we confirm the hypothesis and that is true. So in this way, we can conclude about deductive reasoning. So next we will move on to inductive reasoning. So it is another type of reasoning which is specific to general inductive reasoning is a form of reasoning to arrive at a conclusion using limited sets of facts by the process of generalization. Basically, we are generalizing whatever the information we are having. So based upon that, we are concluding by doing the generalization. It is slightly different from that deductive reasoning, where all the informations have to be true and our conclusion is also true. But here, the conclusion may not be exactly true because we are doing the generalization of the information what we are having. So we can conclude that it may be logically true, but may or may not be realistically true. Here, and propositional logic we will see after the completion of the reasoning, and can look upon one example. So one premise is that all the pigeons we have seen in the zoo are white. So conclusion can be, therefore we can expect all the pigeons to be white. So the premise is telling that all the pigeons in the zoo are white, but the conclusion may not be true also, as pigeons may be of different color. So, but here in the conclusion, we are telling that we can expect all the pigeons to be white. So basically, the uh, information we are having is logically true, but the conclusion we are deriving may not be true. And here also we have we can see the diagrammatic representation of the inductive reasoning, where the general conclusion is drawn from specific observations, and it starts with the observations of specific instances or phenomena. The observation here we can see that the pigeons are white in the zoo, so we are having some observation. Then we will identify the patterns in the data that suggest relationships or trends. Then we will formulate a hypothesis based on those patterns, and we will develop a theory if the hypothesis is consistently supported by further evidences. Uh, the as I've already mentioned that the conclusion may not be uh, true as the premise is. We can also conclude that worldwide it can be true, but it cannot be proved to be true. But to prove it to be false, we will require additional information so that we can tell that the information is false. So moving on to next type, abductive reasoning. Abductive reasoning, we can say that to give explanation or conclusion from a single or multiple observations we have seen or observed. So already we have seen one single or multiple observation. Based upon that, the explanation or conclusion we will make. So it will be our abductive reasoning. It's an extension of deductive reasoning, but the premises do not guarantee the conclusion. Premises, suppose we are having some information, so it will not guarantee that the conclusion we will derive will be fully based on the premises. With example, we will see. Suppose we are having the implication cricket ground is wet if it is raining. So axiom will be cricket ground is wet, and the conclusion we will make that it is raining. We can conclude that it is raining by simply observing the observation that the cricket ground is wet, and it is wet if it is raining. So we can conclude that it is raining. Then the fourth type of reasoning will be common sense reasoning. So common sense, you all know that what we call that it is an informal form of reasoning which is gained through experiences. We generally know if we are doing something, then it will be right or wrong. So based upon our common sense, we can judge. So it relies on good judgment rather than exact logic and operates on heuristic knowledge any heuristic rules. So heuristic knowledge and heuristic rules is simply the mental shortcuts or strategies that simplify the decision making and problem solving processes, which enables us to have quicker decision making. So based on the common sense only, we are just making the conclusion without further having any without further applying any logic. So two examples we can see here. One person can be at one place at a time. So we all know that one person can be at one place at a time only. We will not look further. Uh, we will just have our common sense. So based upon that common sense only, we will say that the person cannot be at two places at a time. So that is common sense reasoning. Also, if I put my hand in a fire, so then it will burn. So we all know based upon the common sense only. Then moving on to the next type of reasoning, monotonic reasoning. So monotonic reasoning is the conclusion taken once, then it will remain the same even if we add some additional information to the existing information. Means if we are having some information, then after that, if we add additional information to it, then it will not change. It will remain the same only. Monotonic reasoning is not useful for the real-time system, as in real-time system, facts get changed, so we cannot use monotonic reasoning. So in real-time systems, the data every time it changes and some additional data comes and go. So based upon that, the reasoning also changes. So we cannot use the monotonic reasoning for that reason. Means it's a kind of theorem which is already proven. Like Earth revolves around the sun. We all know that it revolves around the sun. So if we add another piece of information to it, suppose the moon revolves around the Earth or Earth is not round, etc. So the fact will not change even if we add these three sentences together also. So this is the monotonic reasoning. Next will be non-monotonic reasoning. So it is just opposite to the monotonic reasoning what we have seen in the previous type of reasoning. That the information gets invalid if we add some more information to our previous knowledge or information. So it deals with the incomplete and uncertain models. So every time the new data is added, then the conclusion may become invalid. With an example, we will see birds can fly, penguins cannot fly. PT is a bird. So these three information we already have. We can conclude that PT can fly, as we have already have the information birds can fly. So based upon that, we can conclude that PT can fly. But if we add another sentence to it, PT is a penguin, then we can conclude that PT cannot fly. Since in the previous information we have the information that penguins cannot fly, so based upon that, the conclusion will be that PT cannot fly. So this kind of reasoning will be your non-monotonic reasoning. So till now, do you have any question?
Hello.
Yeah.
Yes, I have a question.
Yeah.
That is this non-monotonic reasoning isn't it same with the inductive reasoning because it also comes with the observations also. This non-monotonic
This,
reasoning, yes,
yeah. So this was just the observations what we were having. But in
yes,
that non-monotonic reasoning, there we have some data. So if we are adding additional data, then it is changing. But in inductive reasoning, we already have the data, and from that data, we are having the observation and we are giving the conclusion. So here the data is not changing.
Oh,
Already the existing from that existing data, we are having the observation. So we cannot tell both are same. Are you getting?
yes, yes.
Yeah,
And this monotonic reasoning is also can be used for the universal logics, right?
yeah. Just we have already seen that it is uh, like a kind of theorem that already it is established. So it is proven only. So we will not look upon the proving part. So it's already there. So we will directly follow it.
Thank you.
oh.
So any more questions?
Hello, sir.
Yeah,
So deductive or non-monitoring are same, like same, right?
yeah.
Deductive and non-monitoring. Logically true.
Deductive is not exactly your it's true only. Already the information you are having is true, but it is not kind of theorem. So it's true basically. So monotonic is already theorem, and we will not look into further proving that. So here in deductive, we are based upon the two uh, piece of information. Based upon that only, we are having the conclusion. We are deducing the new information from the already given information which are logically true. So we are just deducing that directly. And in monotonic, we are not deducing; it's already proven. So if it is true, then it is true. I also request you all to note down all the types of reasoning, and you can see the further examples. Then you can get the idea better. Any more questions? Any in the next class, as I've already told, that we will see the propositional logic in AI. For today, we will only see the reasoning.
অকণমান দেৰি চোৱা মই ক্লাছত পঢ়ি আছো কিতাপ দেই চাউণ্ড কমা
So everyone just try with different examples of the different types of reasoning. Then the picture will be more clear. Any more questions? Or today we'll end here only.
Sir,
Yeah.
you have written this deductive reasoning is a type of propositional logic in AI.
Yeah.
In the first slide. So
Mm.
these other reasonings, like inductive, abductive, other all, will it be not the propositional logic? Because I have no idea about this propositional logic.
Yeah, that I've already told that when we will sing that proportional logic, then we will discuss it further. How
Okay, sir.
it is coming as propositional logic type. Okay.
Okay,
In the next class, we will discuss about that proportional logic. Then it will be more clear.
okay, sir.
Yeah. Okay, then if we are having no any question, then we can conclude here. So our next class will be on Monday, and alternate days we will take Monday, Wednesday, and Friday. So in between, if any holiday comes, then we can adjust that class in the next day also. Okay, class. Then if you are having questions, you can put it in the group also. Then we will discuss in the group. Okay, then. See you in the next class.